Hi, let's start with designing the game window. To use Pygame in our code, we need to import the library. So insert this code, import Pygame. Define the width and the height of the game window. Values determine the size of the window where our game will be displayed. We'll make the window 300 pixels wide and 300 pixels tall. Colors are represented as RGB values, where each component represents red, green, and blue, ranges from 0 to 255. For example, we'll use a bright blue color for our background. Hence, the value is 00255. Create the game window using Pygame library. This window is where our game will be displayed. We use an infinite loop to keep the game running until we decide to close it. A while loop in Python is like a repeating command. It keeps doing something as long as certain condition stays true. We do this by filling the entire screen with the background color. Same code as before. Once we have drawn everything we want to show in this frame, we need to update the display to make it visible to the player. So this is your game window now. Feel free to customize the color according to your preference. Full code is accessible here. For activity 2, we will define the player. We'll use a green square to represent the player. Add the following code after step 1.4 and before step 1.5. We need a function to draw the player character on the screen. This is the codes that are required. Python allows you to define your own functions, known as user-defined functions, UDF. UDF enables you to encapsulate reusable blocks of code for better organizations and readability. Def keyword is used to declare a function. Function name is the name of the function you choose. Parameters are input values passed to the function. Function bodies contain the code to be executed when the function is called. Return statement is used to send a value back when the function is called. We call the function in the game loop. Add the following code after step 1.6. So, this is a player in your window game. Now, customize the player to become a rectangular. Next is to set the player movement. These are the codes that would detect keyboard input and update positions of the player. This code should be inserted inside the draw player function and before draw rectangular command. A for loop is a control structure that allows you to iterate over a sequence of elements, executing a block of code for each element. For keyword initiates the loop. Element is a variable that takes on each value from the sequence. Sequence can be a list, tuple, string, or any other iterable element. This is a for loop example in Python. This is the final code of step 3. Welcome back to step 4 of our game journey. In this step, we'll delve into the world of enemies and their dynamic movements. Enemies play a crucial role in games. They introduce challenges, obstacles, and excitement. Understanding how to create and control enemy characters is a significant milestone in game development. In Python, we have a special library called Random that adds a touch of unpredictability to your games. With import random, you can tap into the power of randomness. This library is your go-to for generating random numbers, making games more exciting, simulating real-world scenario, and adding an element of surprise to your Python projects. With random, you can add unpredictability to your programs, making them dynamic and engaging. Imagine creating a game where the enemy's movement or power-ups are unpredictable. That's the magic of random. Add this code below import Pygame. The enemy will be represented by a red square that falls from the top of the screen. Add this code below draw player function. Let's break down the code that creates and set up our enemy. In this code, we are creating the enemy character, giving it attributes and positioning it within our game environment. First, we define the color of our enemy character. It's red in RGB format, represented by 25500. Next, we declare global variables for the enemy's position and size. These variables x_e, y_e, enemy_width, and enemy_height will be used throughout the code to control the enemy. We set the initial size of the enemy to 20 pixels, both width and height. This determines the character's dimension. Now, let's talk about enemy's position. We use random, randit, 0, width minus enemy width to set up the initial x coordinate. This places the enemy randomly within the game width, ensuring it doesn't go beyond the screen. Finally, we set the initial y coordinate of the enemy to 0. This means the enemy starts at the top of the screen. As the game progresses, we'll update the coordinate to make the enemy move downwards. Remember, this is pixel coordinate. With these initial attributes and positions, our enemy character is ready to take its place in the game world. Stay tuned as we bring the enemy to life with dynamic movements in the next steps. Let's dive into the details of this function. First, we access global variables that we previously defined. This includes the enemy's position, dimensions, the game's width and height, and the enemy's object. We create the enemy character using PyGameRect, a function that represents a rectangle. A rectangle serves as our enemy character. Now, let's animate the enemy's movement. We check if the enemy's y coordinate is within the screen height. If so, we move the enemy 5 pixels down. If the enemy goes off the screen, we reset its position. The y coordinate is set to 0, positioning it at the top of the screen, while the x coordinate is randomly chosen, allowing the enemy to reappear at different horizontal positions. The final step is to draw the enemy on the screen using PyGameDrawRect. This function paints the enemy rectangle with the red color we defined earlier. With the drawEnemy function in place, we are now able to see our enemy character in action, moving down the screen. Stay tuned as we continue to add exciting features to our game. Now that we have defined the drawEnemy function and set up our game environment, it's time to introduce our enemy character to the game loop. In this step, marked as 4.4, we seamlessly integrate the drawEnemy function into our game loop. In step 1.6 before, we begin by filling the game screen with background color. This clears the previous frame, preparing the canvas for our next move. As we are creating a complete game experience, we continue to draw our player characters on the screen using drawPlayer function in step 2.3. Now, the exciting part of step 4.4. We call the drawEnemy function right here within our game loop. This is where our enemy character with its defined color and movements come into play. To ensure the game runs at a manageable pace, we have added a small delay using pygame.time.delay50. This controls the speed of the game, allowing for smoother gameplay. This is how the initial code looks like. Now, make the enemy into a circle. Feel free to explore Pygame library at the pygame.org.
Let's look at the heart of our game development journey. Step 5. These steps is all about collision detecting and scoring. As you'll soon discover, this is where our game truly comes to life, with elements interacting and scores climbing. Collision detection is the magic that happens when our player character interacts with the enemy character, making the game challenging and thrilling. But what's a game without a score? So in step 5, we'll learn how to create a scoring mechanism that keeps track of the player's performance. Step 5.1 is a pivotal movement in our game development journey. This is where we initiate Pygame, the powerhouse that brings our game to life. In this step, marked as step 5.1, we take the first step towards creating a dynamic and interactive gaming experience. Pygame is a Python library designed for creating video games. It provides us with the tools and functionalities to build games from scratch. And the gateway to this incredible world of game development is a simple line of code, Pygame init. This function initializes the Pygame library, setting the stage for an endless possibilities. In step 5.2, we are diving into the world of scores, a vital component in any game. Scores not only track the player's progress, but also add competitive edge to the gameplay. Let's explore how we are initializing the score in our game. First of all, what is the score? The score is a numerical representation of the player's performance in the game. It can signify success, challenges, and the pursuit of improvement. To make the score accessible and modifiable across different parts of our code, we declare a global variable named score. We initialize the score to 0, a starting point from which our players can begin their gaming journey. As our game progresses, this score will keep track of the player's accomplishments, whether it's defeating enemies, achieving objectives, or collecting rewards. Score also ignites the competitive spirit. Players strive to beat their own records and climb the leaderboard, adding an extra layer of excitement to the game. Next is step 5.3. This is where we define the collision function, the magic behind detecting interactions and scoring. In this step, marked as 5.3, we unveil the logic that makes our game dynamic and engaging. So, what is collision function? The collision function is our game's detective. It's responsible for detecting when the player character collides with the enemy character. To ensure that our collision function can access and modify essential variables, we declare player, enemy, and score as global. The real action happens here. We check if the player's rectangle collides with the enemy's rectangle. When this collision occurs, we celebrate the player's achievement. Every collision is a point earned, a scoring mechanism. We increase the score by 1 when a collision is detected. It's this simple line that adds value to every player action. But what's a score without being displayed? So, we create a text label, score X, where X is the current score. To make it look good, we choose a font size, and font color. It's your chance to add an aesthetic touch to the game. And finally, we display the score label on the screen. It's a small but essential element that keeps players informed and engaged. The collision function is our game's watchful eye, as we have seen in previous slides. It's responsible for detecting interactions between the player and the enemy. In this step, we make the magic happen. We call the collision function within our game loop right here. When the player and enemy collide, the collision function doesn't just detect the interaction, it also celebrates the player's achievement. Every collision counts. every time the collision function is called, the player score is updated. It's this dynamic aspect that keeps the game engaging. With the collision function in action, we are now tracking player accomplishment and adding an exciting dimension to our game. Activity 6 is a crucial step in our game development journey. In this activity, we'll explore the art of implementing a game timer. A game timer isn't just about measuring time, it's a dynamic element that can add excitement and challenge to our game. A game timer plays a vital role in setting the pace and creating a sense of urgency. It can be used for time-based challenges, creating suspense and enhancing gameplay. In this activity, we'll dive into the mechanics of creating a countdown timer. We'll learn how to start and manage a timer, display it on the screen, and utilize it to set new objectives for our players. With a game timer, we can elevate the game experience, bringing new layers of depth and excitement to the adventure. Each introduces the element of time as a factor for success. We'll also explore the visual aspect of the countdown timer. It's not just a clock, it's an integral part of the game's interface and aesthetics. We'll design it to fit the game's theme and style. As we progress, we'll unveil the magic behind managing time in our game and how it transforms the player experience. In step 6.1, import the time libraries to access the necessary functionalities. Put it on top of the code with the other libraries. We start by initializing the start time variable. It captures the current time, becoming the reference point for our game's time management. Timing is everything in the world of gaming. It introduces a sense of urgency, deadlines, and creates time-based challenges. It's the invisible force that adds excitement to the player's experience. As we embark on time-based adventures, we need a way to manage the time state. We start with game over, initialized as false, signifying that the game is not over. With these variables in place, we are ready to control time and creating thrilling time-based challenges in our game. Next is to look into the timer function. The timer function is our timekeeper. It tracks the elapsed times, displays it on the screen, and decides whether it's game over. We'll start by calculating the total time that has passed since the game began. It's a fundamental part of time management and sets the stage for time-based challenges. Time is not just a number, it's an element on the screen. We create a time label, select a font, and display it at the top center of the game interface. The timer function also serves as our game over judge. When the elapsed time surpasses 30 seconds as being set here, it signals that the game is over and returns true. If, however, the elapsed time is 30 seconds or less, the game continues, and false is returned. It's a dynamic way to keep players engaged. With the timer function in place, we are ready to manage time, create challenges, and set the conditions for victory or defeat. Next, step 6.6 is to modify the original loop of while to while not, game over. In our journey to master time-based challenges in our game, we have reached step 6.7. This step involves calling the timer function, a key element in managing the game's time. Let's explore why this step is vital to our time management. The timer function is the guardian of time in our game. It tracks time, displays it on the screen, and decides when the game is over. In step 6.7, we put our timekeeper to work. We call the timer function within our game loop, right here. With the timer function in action, we introduce time as a dynamic game element. It's not just a clock, it's a challenge, a countdown, and a game-changing force. As we call the timer function, it dynamically manages game over condition. When the timer exceeds 30 seconds, it signals the game over, adding a sense of urgency and challenges. With step 6.7, we are embracing the power of time in our game. It's time to create thrilling time-based challenges and adventure. This is the initial coding. Look at the time, it is counting up. Now, for the next exercise, change the time to become a countdown timer, as shown here. As we call the timer function, it dynamically manages game over. With the timer exceed 30 seconds, it signals the game over, adding a sense of urgency in the challenges. We define two color constants, dark blue and white, using RGB values. This color will be used for background and text. Add the codes after the while loop. Make sure they are outside the while loop. The screen.fill function is a function that fills the entire screen with dark blue color, creating a background. In this phase of our game development journey, we enter the game over moment. It's here that we display the game over message and the player's final score. The step is about recognizing the player's achievement and concluding the gaming session on a high note. The game over message is a crucial element in concluding the time. It signifies the end of the player's journey and adds a sense of closure to the gaming session. In step 7.3, we display the game over text on the screen. It's a simple text, yet a powerful way to acknowledge the player's effort and signal the conclusion of the game. But we don't stop there. In step 7.4 is where we recognize the player's achievement. We display the final score, providing feedback on their performance. With the final score displayed on the screen, players can see the results of their efforts. It's a moment for reflection and celebration of their accomplishments. As we approach game over moment, we add depth to the gaming experience, celebrating the player's journey and achievements.